Hello everyone and welcome to our Java design pattern series. Today we are going to delve into the adapter pattern. We'll learn what it is, when to use it, and its advantages and disadvantages. So what exactly is the adapter pattern? Imagine you have two classes with incompatible interfaces that need to work together. This pattern acts as a bridge, allowing them to collaborate seamlessly. It's like a universal adapter you would use for your electronic devices from different countries, making them compatible with your sockets. But when should you use the adapter? Well, it's handy in several scenarios. For example, when you're integrating new components or libraries into your code base and when they don't match the existing code's interface, or when you want to reuse existing code without modifying it. For example, in this drawing that I have on my screen, you can see we have some old system which has the doWorkOld method. And then we have a new system, which is a new interface, which has the doWorkNew method. And basically what we want to avoid is implementing this new system into the old one. We don't want to have a dependency between them, or we can't have it or something like that. And in this case, we introduce the adapter. And in the adapter, we're going to be injecting the old system, and we're also going to be implementing the new system. Basically, then this will allow us to directly call the adapter doWorkNew, which will then in turn call the old system doWorkOld. We'll take a look at the code example for this one a bit later. But first, let's talk about the advantages of using the adapter pattern. It solves the interface compatibility issue, promoting the code reusability. It will also maintain the open-close principle, allowing you to add new functionality without altering the existing code. And it will also improve the code separation and modularity. But of course, like any design pattern, the adapter pattern has its downsides. It can lead to more complex code base with multiple adapters. It may introduce performance overhead when translating between the interfaces, and it requires a careful design to ensure that the adapter behaves correctly. In summary, the adapter pattern is a valuable tool when dealing with incompatible interfaces. It helps your code play nicely with others and encourages code reusability. However, like any other tool, it should be used carefully and with a good understanding of your project needs. Before we end this video, let's have a look at some code example. Okay, now we are back into IntelliJ. I have prepared two examples for you. Let's take a look at the first one, which is exactly what we had in this drawing before. We have our old system, and in the old system we have the doWorkOld method, which just prints some text. So nothing special happening here. And then we have our new system, which is an interface, and it expects us to implement the doWorkNew method. As we said, we want to avoid implementing this new system directly into the old one because we don't want to modify this code. And for this reason, we introduce the adapter. We are introducing the old system to new adapter, which is then implementing the new system. It's injecting the old system into this one. And then whenever the doWorkNew is called, we are calling back the old system doWorkOld. And then we have some other class called system client, so it doesn't really matter, which is just Spring Managed Bean, so it's some kind of component. And here we are basically building our adapter. We're providing it with an old system, and then we're just calling the adapter doWorkNew. And this will then, if we jump to it, call the old system doWorkOld. Once we start our application, we're actually going to see this printed. But let's close this one and let's have a look at the other example to maybe make it a bit more clear. In this one, we have some kind of temperature sensor. So it's again a Spring Managed Bean, and basically all it does, it returns us a temperature in Celsius. So this would be our old system, like in the previous example. And now we have introduced a new provider, so a new interface, which then expects to get the temperature in Fahrenheit. And we want to avoid implementing this one in the temperature sensor. And for this reason, we are introducing the temperature sensor adapter. So this adapter will be implementing the provider, and we are going to be injecting the sensor here. And then whenever the get temperature Fahrenheit is called, we're going to be getting the temperature in Celsius from the sensor, and then we're going to be converting it into Fahrenheit and returning it back. Now, since all of these classes that I mentioned, except the interface, are the Spring managed beans, so we have these annotations on them, it means that in the weather station, so our, like in the previous example, the system client, so in this service here, so in the service class, we can just inject the interface directly. We don't have to inject the adapter. That would also work, but we can inject the provider directly, and Spring is smart enough to figure out, okay, this provider is implemented in the adapter, so I'm just going to be calling that one. And basically what you do now is you go to the provider, you get the temperature in Fahrenheit, and then just print it out. And if you're going to call this one, it will actually be just implemented in the adapter, which will then do the conversion. So let's start our application, and we should see both of the lines from both of the examples printed. You can see here doing old work, and you can see the 77, so the temperature that we are printing. And you can see both of our examples work perfectly. Great. Then, if you have found this video helpful, don't forget to like and subscribe for more content on Java design patterns. If you have any questions or suggestions for future topics, feel free to leave them in the comments below. Thank you for tuning in today, and we'll see you in the next video. Happy coding!